So let's see, what we're going to do today, which is a little different from what we've done in the past, is just go through the Tesla history. So starting from the beginning and then adding, coming to present day and then talking about the future, which I think people know like little bits and pieces about, but I think it's important to explore the history and the motivations and the decisions along the way, so that people understand like what is Tesla all about? What does Tesla mean? Like why are we doing these things? And the decisions of the past inform the decisions and motivations of the future. And people have, I think, by now heard quite a bit about the master plan blog that I wrote sort of a decade ago. I actually wrote it more than a decade ago, but it got published in 2006, and it was always the plan from the beginning, because it's the only plan that I thought had any chance of success, which is to start off with a low volume car that would have a high price because we didn't have the economies of scale, and we had no idea what we were doing. Like we had no, like how the hell do you build a car? Like no idea. It's got wheels, it's got a body, it's motor, like all sorts of other things that we don't know about. So being basically completely clueless, we had to do something that was simple and we knew it would be expensive because we didn't have economies of scale, and we couldn't even, a lot of times, even get suppliers to even call us back. Like, they were like, "You're who? What? Never heard of you. Bye." Like, that was the usual response from suppliers. And so we had to start off with something that was straightforward and that was going to be expensive and low volume. And then step 2 was to have a lower price, higher volume car. And then step 3 was to sort of finally get to something that was high volume and affordable, which is the Model 3 that we unveiled just recently, just a few months ago. And then, of course, there will be many more vehicles and models from Tesla in the future. But the Tesla master plan is really just kind of like a very limited perspective on Tesla, and it's really, I think, worth going into a more detailed look at the history and the decisions and motivations, and most importantly, I think I really want people to understand like the decisions we've made along the way. We've really always tried to do the right thing. Like we really care about that, and when we make mistakes, it's just because we're being foolish or stupid or whatever, but it's really always made with the right motivations, and it's never meant to be sort of something that we don't. We say the things that we believe, even when sometimes those things we believe are delusional. So we're going to do a look into the history of Tesla. And I'd like to welcome JB to the co-founder JB. So today, and we're going to bring in a number of people that were at Tesla from the very beginning, kind of just to tell anecdotes and stories. And this may go on for a while. So if you find yourself getting bored, I won't be offended if you want to leave. And so this may go on for a while, and then we're going to have a Q&A and try to get to all the substantive Q&A stuff, and go as long as as people really want to go. So look into the long and somewhat sort of soap opera-like history of Tesla. I mean, there are many episodes to the soap opera. It's like a multi-season situation. So really, even this history is, it's really glossing over a lot of things, but I think we'll still give people a really good sense for how things started out, what led from one thing to the next, why did we do this versus that, and just understand really like what happened, because there's there's a lot out there that some of it's correct, some of it's false, or some of it's quite patchy. But I think hearing it from the people on the ground at the time is really helpful. So the way things really started out was with the AC Propulsion T0. So AC Propulsion is a little company in Southern California that deserves a huge amount of credit and doesn't get enough credit. So we really want to give them just a ton of credit for the concept of doing an electric sports car.
Yeah, in fact, my first ride in an electric vehicle was in a car that Alan Cocconi, who was the principal engineer and one of the founders of AC Propulsion, built. And I was back in college still at the time. But that's part of what convinced me that EVs had such an amazing potential and such an amazing future. And I think, as Elon said, they deserve a lot of credit for having laid the technology foundation, very early on for what this next generation of EVs could actually do.
Yeah, exactly. So the AC Propulsion T0 was a lithium-ion powered electric car using cylindrical cells. They actually started off with it being lead acid and then upgraded it to lithium-ion cells early in 2003. I think it was early 2003, approximately then. And the specs for the T0 were very similar to the specs for the Roadster. So it had a roughly 250-mile range, roughly 4 seconds 0 to 60 time, and a lot of the specs were quite similar to the Roadster where we commercialized it. It did have some drawbacks, like it did not have a roof or doors, or any safety systems.
Any airbags.
Or airbags. And the battery was air-cooled instead of liquid-cooled, so it would overheat very quickly. So it was certainly not something that you could sell to the general public. And it also, the production cost of a T0 was, I think, basically like $300,000 or $400,000, like really, really high. But the basic concept and capabilities were demonstrated by AC Propulsion well before Tesla was created. So I'd just like to, frankly, just give them a round of applause for that. It was like, so I mean, like I said, they deserve a ton of credit and don't get enough. And in fact, in 2003, JB and I had lunch basically in LA, taking El Segundo. At the lunch, we sort of ended up talking about EVs. It was, I'm not sure how the lunch exactly got set up, but
I think I was trying to get you to invest in an electric airplane.
Yeah. Electric airplanes. How intriguing. Still dying to do that. So the lunch that we had in 2003 was really ultimately what led to Tesla as it is today. And in that lunch, I mentioned to JB that, I've been interested in electric cars since I was a teenager, and thought that was really what cars should be from a fundamental physics standpoint. Like, it's super obvious from a physics standpoint that electric cars are the right way to go. And I obviously believe that very strongly. And in the future, people will look back at the era of gasoline cars in the same way they will look back on steam engines. Like, it was interesting, it's quaint, it's interesting, but it was sort of like a phase, And then really electric is the way. I'd actually originally come out to Silicon Valley to do a PhD at Stanford in advanced energy storage technologies for electric vehicles, with the idea of potentially focusing on ultracapacitors with high energy density as a potential solution. And then ended up putting that on hold to start an internet company, Zip2, and then co-found another one, PayPal, and then finally, after all that coming, kind of like, okay, time to get back to electric vehicles. So sort of circle back to that. And JV, I think, had sort of maybe a slightly less circuitous path. But you were doing like Rosen Motors.
Yeah, I was trying to build hybrid electric cars with gas turbines and a flywheel, which was kind of an ill-fated idea, but batteries weren't as good as they were at this point. Turns out containing a flywheel in a moving car is not a very good idea.
Tricky.
But even more recently than that, I had started spending more time experimenting and understanding lithium-ion batteries, which were sort of brand new in the early 2000s. They were just coming on the scene for laptops and other electronic devices. And I had gotten to know AC propulsion. I had, coming out of school, followed them for a long time and actually thought about going to work there, but it seemed like a little bit of a shaky enterprise. But they were doing some amazing work and really interesting learnings with lithium-ion batteries. So I was spending quite a bit of time trying to figure out how could we adapt lithium-ion technology into a much larger pack to take vehicles long distances.
Yeah, and it kind of makes sense. Like when GM did the EV1, initially with lead-acid batteries, it had a range of about 60 miles. Lithium-ion has 4 times the energy density, these days more than 4 times the energy density of lead-acid. And so just basically, if you just replace the battery pack, you go from a 60-mile range to maybe a 240-mile range. So really, like, the basic math was pretty obvious, but despite it being fairly obvious, nobody was doing electric cars. In fact, at the time, in sort of 2003, 2004 timeframe, electric cars had gotten sort of a really bad reputation, and the industry, the auto industry, had concluded that electric cars were a waste of time and basically couldn't make a compelling electric car. And even if you did make a great electric car, people wouldn't buy it because they love gasoline so much. So like, okay. So I got based on JV's recommendation, a test ride in AC Propulsion's T0 in 2003, and I was like, wow, this is awesome. And I tried my hardest to convince AC Propulsion to commercialize the T0. I mean, I can be pretty persistent about these things, and I was like, guys, you've got to show the world that this is like real, and prove to the industry that they're wrong about electric cars. So I was hounding like Dan and Al, like, guys, come on, just commercialize the T0. And then it's like, okay, look, if you want to commercialize T0, can you at least make one for me? Like, no, they don't want to do that. Okay. Like, can you convert my current car to an EV? No. Okay. Then finally, it was like, I was like, okay, look, guys, if you're sure you don't want to commercialize, you don't want to do a commercial version of an electric sports car, do you mind if I do that? And they're like, no, that's cool. We're cool with that. So then they, so my initial plan was just basically to just get together with JB and say, hey, JB, let's form a company and essentially commercialize the T0 concept and create an electric sports car. And then the AC Propulsion guy said, well, there's some other groups that are also interested in doing the same thing. Why don't you team up with them? And so that's when we teamed up with Martin, Mark, and Ian and created Tesla. So that's sort of kind of how it happened. But I think it is important to emphasize, like, when we created Tesla, it wasn't from the standpoint of like, hey, this is a great way to make money. It was like when I told my friends about this, they're like, you're crazy. Like, how much money do you plan to lose? Not will you lose money. How much money are you planning to lose?
It was a pretty crazy idea. I was trying to convince all my friends to join and come and work at the company, and even some people that were building electric cars didn't want to come and join because they thought it was too risky. So it Yeah, it's hard to understate how untrendy electric cars were at that time. Everything was focused on the internet and no hardware companies, nothing even remotely like building a whole car.
Yeah, I mean, basically, like in 2004, the idea of starting a car company was considered extremely stupid. And then the idea of creating an electric car company was like stupidity squared. It's like, wow, that's dumb. Okay. And so I'm a big believer in like don't ask investors to invest if their money if you're not prepared to invest your money. I really believe in like the opposite philosophy of other people's money. It's like it just doesn't seem right to me that that if you ask other people to invest that you shouldn't also invest. And in my opinion of the success of Tesla at that point was so low, I thought maybe optimistically we had a 10% chance of success. So I actually put it's essentially 99% or thereabouts of the Series A was money that I made from PayPal. And just because I'd rather lose my money than any of my friends' money or investors' money. And I thought, wow, this is really probably not going to work. And if I lose the money, it's not the end of the world. And so the beginning investment was really just all me, not from the standpoint of like, oh, this is a great way to make money, but just actually, I didn't want to have it on my conscience that other people had invested and then I'd lost their money. And if they'd asked me what my opinion on the likely success was, I would say very low. So, yeah.
And even most of the early employees had kind of a similar mentality. I think we knew that it was going to be incredibly risky and the odds were against us, but everyone believed in the mission so much, and they believed in the possibility of the technology and the change that we could create, that it's worth taking the risk. Even if it was 10%, if you can make this much positive good on the world, why not take that 10% shot?
Yeah, exactly. So, yeah, I think we pretty much all thought, well, this is probably going to fail, but it's worth a shot. And because the big car companies had abandoned electric vehicles, it's like, man, if the big car companies don't do electric vehicles, and then the only option is for a startup to do electric vehicles. And even though the historical track record for automotive startups in the United States is extremely bad, if you look at, say, today, the only two American car companies in history that have not gone bankrupt are Ford and Tesla. Okay? So I'm just getting like the move it, get moving sign from the back. Anyway, like I said, this one's going to go long, and I totally won't be offended if you want to leave, because we're going to cover a lot of ground. So if you have other obligations or it's like getting tedious, please, don't feel obligated. So. So that was like the beginning of it, and like I said, we felt we had to create a startup car company because the big car companies had all abandoned electric vehicles and everyone thought they were dumb, and General Motors was in the process of recalling their EV1s and then taking them to a junkyard and crushing them so that nobody could ever use them again, which I thought was just a terrible tragedy. And people wanted their EV1 so badly that they were so sad about it that they held a candlelit vigil at the junkyard where the cars were crashed. Like, who holds a candlelit vigil for a product? Ever? It's a GM product. I mean, it's like, so like, I don't know what kind of wake-up call you need to say, like, maybe you shouldn't end that program. But if people are holding candlelit vigil like it's like someone's about to be executed, then you should really say, wow, maybe we should not cancel that program. Anyway, but that was like the situation. Gasoline was super cheap, $2 per gallon gasoline. Anyway, so just like, it was definitely not from the standpoint of like, oh, this is going to be a great investment and a way to make money. It was just like a terrible investment and we're probably going to die. So, anyway, so nonetheless, we got going. And the first thing we did was to create sort of a Tesla test mule, which was to take a Lotus Elise, sort of, and then highly modify it to add the Tesla battery pack and the AC propulsion drivetrain. And this is, I think, a point that may be helpful to entrepreneurs out there that are, creating companies. The reality is that like the creation of Tesla was based on two fundamentally false premises that turned out to be, in retrospect, staggeringly dumb. So the one was that we'd be able to use a Lotus Elise, a sort of slightly modified Lotus Elise, add an electric powertrain using AC propulsion technology, and then be done, and that would work. And in reality, when you convert a car to electric, and you want to make it something that passes all of the federal safety standards and all the legalities necessary for a road legal car, you actually you invalidate all of the crash tests, and the battery pack ended up being too big to fit in the car, so we had to stretch the chassis, and we couldn't use the air conditioning system because that was previously run off of the motor or the engine power. So we need to have a new AC system. We had a new wiring harness.
All new suspension, all new brakes.
All new suspension, all new brakes, because the car was 30% heavier. The body was all different. In the end, only about maybe 6 or 7% of the Tesla Roadster had parts in common with any other car, period. Okay. And so it ended up actually being much worse than if we'd simply designed an electric car from scratch. It's like if you have a particular house house in mind that you want to build, instead of building that house from a fresh start, you take some existing house, and then you end up modifying everything except one wall in the basement. You're like, okay, that's actually much more expensive and harder to do than if you just design it and build it right from the beginning. And then the AC propulsion technology, while great for a prototype, actually ended up not being producible. Like it wasn't reliable, it wasn't producible, and it wasn't consistent, and it would break down all the time. So I don't know if this is, yeah.
Yeah, I mean, it was pretty amazing. The motor controller, the brain, the computer that actually controlled the motor was 100% analog. I mean, it was this unbelievable invention. I mean, genius engineering to actually make it run at all, but it wasn't something we could reproduce. So among the sort of difficult engineering tasks we took on in the very early days, one was the battery pack, re-architecting the whole battery pack, making it liquid-cooled, making it safe.
Yeah, the liquid-cooled thing was really important because the AC propulsion battery pack, even though it used cylindrical lithium-ion cells, because it was air-cooled, it would very quickly overheat, and it was highly susceptible to a thermal runaway event. So if one cell went into thermal runaway, it would domino to the rest of the cells.
Yeah, and it was also packaged in the doors, which was not a very good place to package the battery pack.
Yeah, it's like, oh, how do I get out? Oh, I can't. It's on fire.
It was either side of the car. So re-architecting the entire battery pack, making it liquid-cooled, and it's still amazing to me how much of if you look at that first Mule and put it next to a final Roadster, they were phenomenally similar, actually. It was a very innovative time when we came up with these kind of concepts and architectures that made it work. But one of the big things were the electronics in that brain to control the motor, and we had to start from scratch. I mean, as Elon said, it would have been more efficient on the car. We did actually do that on the electronics. And some of the key engineers are here still that did that work. Drew Baglino is one of the folks. Do you want to
Drew, why don't you come up?
Maybe you want to share a couple of quick anecdotes or stories about some of those early motor control days?
Sure.
This has been 12 years, by the way. So
Yeah, it has been a long
Drew
time.
was like basically part of like the founding team of the company. So
Thank you, Elon. Yeah, just over 10 years for me now. So I'm on the time scale pretty early on here. But yeah, JB mentioned Alan Cucconi. Alan Cucconi actually, we tried to figure out what some of his circuits did, and we would simulate them and be like, oh, this is what it does. And then 3 months later, we'd be like, no, that's what it does. So it was kind of a learning by doing. But we needed to get out of this ghost in the machine world where we were with the analog PEM. And so we said, okay, about a team of 5 engineers, let's start from zero. Let's start with today's technology, digital motor control using DSPs. And we went out and set to do it as a parallel path so we wouldn't disturb the rest of the validation, because we had to go through crash tests, we had to go through performance tests, we had to run on rough roads for hours with cars that worked. But that didn't deter our determination. So we in like 3 months, we went from the first schematic to a driving car. And I actually remember that first day when we went out driving, and we brought JB along. And it was my first 4-second 0 to 60 experience. And I had never experienced anything like that, but my prior car was like, 80 horsepower Civic or something like that. And it actually held together, and it was an amazing 4 seconds. And that certainly hooked me on electric, and I haven't looked the other way ever since. But after that, we decided to take this car for somewhat of a range drive. So we drove through over to Mountain View to Google. Actually went right by here with one of these digital motor control prototype cars. Colin was in the car. He's back there in the audience.
Hey, Colin, anything you want to come up and say?
And I remember I was staring at the waveforms, and we were like, ooh, maybe we've got a loose ground or something. And sure enough, like somewhere coming back to Redwood City, we actually had to pull over. And I remember JB, we were all like peeling back the top of the PEM cover. We had this like portable screwdriver just for this sort of exact use case. So we probe inside. We figured out it was a loose ground, fixed it, drove back, and we were like wheeling in, eking into the Bing garage with absolutely no power left.
That's St. Collis, the Bing garage, yeah.
Oh yeah, the Bing garage.
It was super tiny.
Super tiny little garage. Yeah. And we almost had to wheel it in, but it actually got in on its own power, and then kaput, it was done. And actually at that point in time, JB mentioned the motor control, but we actually were doing the charge control digital as well, all redone because it was analog before and really unreliable and finicky, especially when connected to like generators or long high impedance lines and things. So, but we hadn't solved the charge control digital for low battery SoC yet. And so we were like, oh no, we need to charge the car. And it was actually doing this, it had this problem, it was a bug at the time. It was doing this like self-destruct thing where it was running the compressor to cool the battery.
Full disclosure sort of.
Exactly. Even though it was the end of the state of charge, didn't make any sense. We were like, oh, we gotta get it on charge. So we ended up unplugging the compressor cable and charging it, backfeeding through like the DC connection of the compressor. But it was a very successful drive, all said. And digital became the plan of record. I flew out to Hethel with some other folks from the team to retrofit all the EPs with...
Hethel is Lotus. That's yes. Lotus's headquarters in England.
Yes. Yeah. So flew out there. We retrofitted everything to full digital. And then we started developing digital traction control, all the pedal feel that everybody still has in their cars today. That all came together for Roadster back then. And it was a ton of fun.
Yeah. In fact, I remember in the early days giving a test drive to Larry Page and Sergey Brin, who I've known for a long time, and there was some bug in the system, and damn it, the car would only go 10 miles an hour. It's like, look, I swear, guys, it goes way faster than this. Anyway, but they were kind enough to put a little investment into the company nonetheless, despite the world's worst demo.
But yeah, that's the digital motor controls story. It was this team of 5 engineers, and we worked in this tiny little power cube for 3 months and got to the bottom of that problem and solved it. And we still build on the leverage of that technology today with all the cars that we have on the road.
Yeah, it was pretty amazing what we could do with small teams and pretty tiny budgets when we had this incredible focus. Every single thing was just solve this problem or else. So.
And that was another thing we learned, right? You can't just take AC propulsion technology and expect it to work. So we really wanted to get the heart of the machine, the heart of the car, into our IP, our code, and this was an opportunity to do that.
Yeah, so essentially when I say like the company was founded on two false premises. One was that you could easily modify an existing gasoline sports car to be electric, totally false. And the other was that we would be able to use the AC propulsion technology that we'd licensed for a production vehicle, also totally false. They'd done some great technology that worked well on prototype cars, but basically did not work at all well for a production vehicle. So anyway, I think the lesson here for people thinking about creating companies is that even if your company starts off based on things that are completely untrue, that you don't know about, what really matters is recognizing the mistakes and adapting quickly, and kind of fixing the sort of the false premises upon which the company was founded. That's what really matters, for people that thinking about creating companies. Just you got to adapt quickly, acknowledge and recognize your mistakes, and the sooner you do that, the better. So.
Should we ask Colette maybe?
Sorry?
Should we ask Colette to share a few stories too?
Yeah. So let's have Colette come on. Yeah. Oh, yeah.
Hello. My name's Colette Bridgman. I'm employee number 9 at Tesla, so I will be coming up on 12 years in July. So a lot of this history, as well as being Elon and JB's history, is my history. I'm super proud to be here. So back to what Elon was saying, is a company founded on an idea that didn't come to fruition. When I was interviewed, I was told that this company would be about 35 people.
Yep.
They had a 3-year business plan. We wanted to commercialize electric vehicles, which sounded brilliant to me, being the only non-engineer at the company for the first year. And that we would outsource everything. So as you guys can...
Well, it turned out to be true, of course.
Yeah. Yeah. So from what you guys know about Tesla, obviously that business plan took a complete 180 in the first 2 years. We're so vertically integrated from the top down. But it just goes back to saying, when you start a business plan and you think that the company is going to be one thing, and what it ends up becoming 13 years later is something totally different. But I think at the core of all of it is a company full of passionate people that are mission driven. And when you stand behind a mission, I think that what you think you can accomplish and what you think you can do isn't paralleled with what you can actually accomplish. So I want to take a moment to say thank you to these two who've been such an inspiration, and to all my fellow employees. We have lots of oldies out here that Drew, every time I look at Drew, I just think about those weekends that they would work in their little lab, and I would have to come in and pick up the paper airplanes from the ceiling and all over the floor, because it was a little bit of like a frat house back then, but super fun. And we've got dozens and dozens of stories about how this MULE came to life, and how we all got here, and it's DNA that runs through the company to this day. So thank you.
Cool, thank you. So thanks, Colette. Colette's made a huge contribution over the company for the company over many years. So thank you for everything you've done. So building the Roadster test mule, and you've heard a lot about that. Then we needed to get to an actual Roadster prototype that was sort of that was more of the production design. And so then we redesigned the body. I was basically the chief designer of the body. So if you like it or don't like it, for Roadster version 1 and 1.5, that's basically me. So, like my two favorite cars were the McLaren F1 and the Porsche 911. So if there's sort of elements of that in the design. I don't think I'm a good designer, by the way. But we're going to get to Franz, who is a really good designer. And actually, it's relatively easy to design a sports car that looks good because the proportions naturally lend itself to excitement and beauty. And it's incredibly hard to make a sedan that looks good. Like that's a whole different level.
Yeah, and this picture in 2006 was actually from our Roadster launch event. So this was a really pivotal event in the company's history. It was the time when we went out of stealth mode. Before this, nobody had ever heard of Tesla. We'd never had a single media article. We'd never taken any customer deposits. We had no customers. We had no sales team, actually.
Nobody had heard of the company. They thought Tesla was a rock band. Or if you're a scientist, Nikola Tesla, of course. But in the public, like, oh, you mean the rock band? Okay, no. By the way, those guys are awesome. They've been huge supporters all the way along, and they never bugged us about the fact that we used their name and everything. Yeah, rock on Tesla, the band.
But this event was awesome. I mean, this was, we had 2 prototypes built at this time. So we had that yellow MULE that we started out with, and then we built 2 working prototypes for this event. There was a red car and a black car. And we had this kind of concept at the time to do an event where we'd give customers test drives, and then we'd start taking reservations. And do it all at some giant big party, maybe at an airport. And this sort of formula became something we started to repeat, and it kind of became the Tesla DNA a little bit of how we would do product launches and start getting customers closer to the product.
This was at the Santa Monica airport, and basically in LA. So.
And it was awesome because we went from 0 to having all these customers, hundreds of them. We thought it was massive numbers, hundreds of them.
Yeah, we really thought that was crazy that like 100 people would buy our car. We had the names, we got 100 people to buy our car. That's amazing.
There was actually a projector, and we'd type in everybody's name.
Everybody's name, yeah.
And put it on the wall because we thought there'd be like 10, but it filled up. So anyway, it was pretty amazing, even though the cars were basically just hardly holding together.
Yeah.
I mean, those 2 cars were basically destroyed by the end of the night. That was most of our durability testing, and we had to drive them behind a curtain and actually pump ice water through parts of the powertrain in order to keep it from overheating, so we could keep going with more test drives. So nobody knew this at the time, and it was amazing though. I mean, we left that event with demand being 10 times what we expected, and a whole ton of engineering challenges to go solve, but we knew for sure that people wanted this car in numbers that nobody else expected they did.
Yeah, exactly. It was a hugely energizing event because we had no idea whether people would we thought maybe nobody will buy the car, except for friends and family or something. But we got total strangers bought the car, which was wow, that's really. Wow. Okay. So
it was a long road. Obviously.
Such a long road.
Much longer than I think we ever expected. From 2006, showing off 2 cars that could do a few test drives at an airport, through to when we actually would need to deliver those hundreds of cars we had sold.
Yeah. Hundreds. I mean.
The cars we rejected for.
Holy mackerel! Jesus. We have an army of cars here.
I'm looking like we're going to be able to deliver 4 cars to the sales team.
This is frightening.
What's going on here is the team has been doing a little bit of rework today. Remember I was talking to you earlier about the vehicle that had the noise?
Drivetrain issue, so we're swapping in the new one right now.
Let's not even wait for the analysis. Just put a new powertrain in, table it for analysis, and let's get it out there.
Absolutely.
Right now we're facing an issue, which is that it's sort of a crisis of confidence among our customers.
Yeah. I mean, if anybody's interested in, I think there's a great movie by Chris Payne, who did a well-known documentary called Who Killed the Electric Car, and then he did a follow-up documentary called Revenge of the Electric Car, and it ended up following 4 car companies, one of which was us. And so he actually, the movie actually follows what was the most difficult time for Tesla in its history, and multiple near-death experiences. So I'd really recommend. I just want to give a shout out to Chris Payne, who's just an awesome dude. And it's like, if you're curious about seeing the early history of Tesla, the Revenge of the Electric Car is a great movie to watch and get a sense for things. We had so many, since as I said, we had no idea how to build a car. We had so many huge challenges with the Roadster. One of the biggest was that the transmission didn't work. And we'd actually contracted with 3 different companies to build the transmission, and because it was originally going to be a 2-speed transmission, because the motor from AC Propulsion, motor design from AC Propulsion, required a 2-speed transmission in order to achieve the specs that we promised for the Roadster. So you could not achieve the 0 to 60 time. You could either achieve the 0 to 60 time or the top speed, but not both, unless you had a 2-speed transmission for an electric car. And the problem is that an electric car transmission is really different from a gasoline car transmission, because the RPM is much higher, the torque transfer is much higher, and so when we'd work with these quite well-known companies building transmissions, the transmissions all broke because they just couldn't take the torque transfer and the RPM. And the first Roadsters that we delivered, which were about a year later, actually still had the bad transmission that our suppliers had delivered us, but we locked it in 2nd gear. So the acceleration was actually not very good, but at least you could get up to highway speed. And then we actually had to we ended up replacing the drive unit for all of the Roadster version 1 cars, because they basically, it didn't work.
I mean, it actually forced kind of a key invention. I mean, we essentially, re-engineered the power electronics and the motor in order to get rid of the gearbox. That was the trade-off that we made in that very early generation. And once we had done that, it was clearly better in basically every single metric. It was lighter, it was more efficient, it was cheaper, fewer parts. So it was definitely the right way to go, but we just weren't ready when we started production. So we had to catch up after the fact.
Yeah, exactly. So, in fact, I remember the conversation that JB and I had flying back from our gearbox supplier, and that was like, man, it's like, JB, we are really screwed.
I think that was the 3rd gearbox supplier.
The 3rd gearbox supplier, we're like, we are screwed. Now we know that if we redesign the motor, we can do this with a single-speed transmission that doesn't require a clutch, which is order of magnitude easier to do than one that does have a clutch and has to shift gears at very high torque and very high RPM. Because essentially, if you have a single speed, then it's just it's not really a gearbox, it's just an RPM reducer. But it required us moving away from the AC propulsion motor design. So we had to redesign the motor, redesign the power electronics that powered the motor, but it was actually easier and faster for us to do that than to try to make the 2-speed transmission work.
It required twice as much torque from the electric motor.
Exactly.
So it was a pretty big redesign.
Yeah, so that's why, I mean, in the end, we didn't use really any of the AC propulsion technology. Even though they did a great job with the prototype, everything had to be redesigned. And anyway, so that's just a minor taste of the Roadster challenges. There's many more. And of course, we received huge amounts of support from the, yeah, I mean, with support like this, I mean, how could you not be energized to solve the solution, figure out the solution?
It was crazy. I mean, even our friends were, sitting there reading all of these death watches, and
our customers are like, "Do you want to buy a car?" Well, it's like I was reading about this death watch thing.
And this was before we'd actually delivered to the customers that had bought the car.
Yeah.
So that was a difficult thing when they're reading about the company that's about to die, who they just bought a car from.
Yeah, exactly. So, I mean, there was quite a bit of schadenfreude in the media who was sort of like, we had the temerity to try to create a car company. It's like, who do these arrogant jerks think they are that they can create a car company? The hell with them. They're just going to die. And there were like multiple blogs maintaining a Tesla death watch. It really pumps you up, Anyway, despite that, we managed to make the first Roadster deliveries in 2008. I got, and the rule at Tesla is whoever puts down the deposit for the car first, that's their order in line. So, I put down the first deposit for Roadster 1, and it got delivered, I think, like February or so of 2008. Now, frankly, this car, although it technically passed all the regulatory requirements for a street legal car, was completely unsafe and broke down all the time. And yeah, it didn't work really. But it was stuck in second gear. But anyway, and it was all hand built. Like the production wasn't working. There were so many issues that we had to redesign the whole production process. From 2008 through 2009, we had to do a complete reboot of the design of the car, the technology, and most of our suppliers had to be changed out in the span of 2 years.
Yeah, we actually started building, per Colette's story, we started building most of the powertrain overseas because we had this, slightly misguided idea that everything must be cheaper and better if built in Asia.
Yes.
So we started building battery packs actually in Thailand in a not very
with a contract manufacturer who, they were well-intentioned but had no idea how to build battery packs.
Yeah, actually, it was a barbecue manufacturer.
It was barbecue manufacturer.
But they were neighbors or friends of one of the other engineering leaders, and we built motors in Taiwan, batteries in Thailand. We had this crazy supply chain, and not surprisingly, it was extraordinarily hard to get good quality product at the rate we needed from these suppliers. So in that time frame, that 2008 to 2009, we had to do some amazing things. Moving those factories, taking control of them, moving them back to California, and then resetting them up completely. Because what we had done in Thailand was utterly inappropriate for what we would do here. And maybe Jason,
Jason, you want to just say a few words? Like Jason was one of the key guys that really made it happen in transitioning the battery pack in particular from a contract manufacturer. Yeah, man.
Thanks, guys.
So, I remember having a conversation with Jason. It's like, Jason, dude, we are doomed if we do not insource the battery pack, because we have a supplier in Thailand that is great at making barbecues but not at making battery packs. And the supply chain is so long that it would take 6 months from when the cells were built to when the battery pack was done and in a car. And so that means we would have to make the capital cost of that supply chain was gigantic, because we'd have to pay for that all of that inventory and process. And then inevitably there would be mistakes made in the design or the fabrication of the battery pack, and we'd have 6 months worth of battery packs that didn't work. So this was like sort of doom on a stick. And it's like, man, even though like the idea of like manufacturing in San Carlos was kind of mad, it was less mad than outsourcing to a situation that definitely didn't work. So it's like, Jason, we have like basically months to insource this operation so that we can iterate rapidly on the battery pack design, iron out our issues, and tighten the supply chain.
Yeah, it was, I started in May of 2005, and it was funny when my friends asked me what I was doing. I would say, well, I can't say much, but this is kind of the gist. They're like, does that have any chance of working? I'm like, no, of course not. But I'm doing it. It's going to be great. And in late 2005, after having made 2 prototype batteries of very different designs, we started work on our 3rd, and also simultaneously decided that we were going to make it in Thailand. And so we were simultaneously designing, in true Tesla fashion, simultaneously designing the thing and building the factory out in Thailand. The CM, like you said, I think, Elon, was extremely well-intentioned, but just absolutely no experience. The building was open to the air, and so you would literally have animal droppings on the product. And that's when we're like, all right, we got to have a building, man. Come on.
Yeah, like, roofs are important, you know. It's like,
And so after 2 years of spending, I spent personally 50% of 2 years there. A bunch of people in this room spent as much, if not more, time there, getting the thing running. And like you said also, the lag, like we would show up in Thailand with, I don't know if you guys know what a Pelican case is, but it's this awesome plastic suitcase. And we'd show up with 7 of them at the airport. And these guys would just look at us, what are you guys doing? And we learned the term tools of trade is kind of a hot button to just go, all right, go. Because trying to get tools and parts. Anyway, we brought it back in January of 2008. We packed up 7 shipping containers, and we reassembled that factory in San Carlos at that Bing Street warehouse that Drew was talking about. We reassembled it in about 5.5 months, and that's where the battery that went in your car came from.
And by the way, just for those that don't know the Bay Area, San Carlos is like basically in the Bay Area. It's you know, like
It's 10 miles up the road.
just 10 miles up the road. So, you know, manufacturing things in the peninsula is like considered super mad.
Yeah, and this was kind of our, you know, it was really early, like telltale vertical integration is the way to go. And some would argue we might have over-centered in some areas in that area, but really we had control now. We had all the engineers right there. We didn't have batteries on the water, not only from Thailand to England, but then cars on the water from England to here.
That's what I mean by the 6-month supply chain. So it would be like, we would only find out if there was an issue with either the design or the manufacturing of the battery pack 6 months after it was built. So you can imagine the insanity of having some built-in design or manufacturing flaw and have 6 months worth of inventory that all has that flaw.
Yeah, some of the same people that we were working with building the factory in Thailand, we would do missions to Hethel, to the UK, to the Lotus factory, again with these Pelican cases full of glue and popsicle sticks and mixers, and we would do these retrofits of, I think the record was like 15 batteries in 2.5 weeks, where we disassembled the whole thing, did the retrofit, assembled it. The Lotus guys thought we were insane, which
they did.
They had a point.
Yeah.
We were.
So yeah, that's a really quick story, kind of about bringing it home. 7 months reassembly.
The motor as well.
Boom. Yeah, we did the same with the motor years later. Yeah. So.
Yeah, so just like congratulations to you and your team on making that happen. That was like an amazing feat. So, yeah.
Thank you. Thank you.
And I think, you know, that taught us a really key lesson that is still incredibly relevant today, which is a lot of the technology and the intellectual property was in how we actually make the products. And I think that's underappreciated by a lot of people, but you know, no one knew how to make these battery packs. So Jason and his team and a lot of the engineering team were inventing how to manufacture the thing that we had designed. And that ended up being, you know, actually more complicated in a lot of ways to do it at rate and at high quality. And I think we learned that appreciation pretty early, and that's helped us immensely to be able to, you know, scale Model S later and eventually Model 3.
In fact, and that sort of foreshadows what I'm going to talk about at the end, if anyone's still around. which is the realization of how important it is to build the machine that builds the machine, and how much harder it is to build the manufacturing system that builds the product than it is to create the product in the first place. I mean, you can create a demo version of a product, or like a few cars worth of a product with a small team in maybe 3 to 6 months. But to build the machine that builds the machine, it takes at least 100 to 1,000 times more resources and difficulty. And it's just not something. I would say only fully came to that realization maybe even just 2 or 3 months ago. Yeah. Like, it's a bit. I'll talk about that at the end, and just how important that is, and how I think very few people really appreciate how important that is, and how important manufacturing and supply chain is. And how I think that's actually the main problem to be solved. But I'll talk about that at the end. So then, the first retail store opened up. This was in LA on Santa Monica Boulevard. It was formerly, I think, a kids' furniture store. And this was like a controversial decision at Tesla. In fact, like the original business plan, Tesla called for using the regular sort of auto dealer network and that kind of thing. But I was really adamant that like we need to improve the buying experience. Like, just I don't know anyone who loves the current car buying experience of, and usually, when people tend to view buying a new car as equivalent to going to the dentist, and maybe the dentist is better, but it's just never something people look forward to. And so we thought, well, look, if we're going to make a new car company, we don't want to inherit the negativity or the sort of the bad elements of how it's been done in the past. We want to fix we want to do it right, and we want to make sure that people love coming to buy a car. They look forward to it. And like the most important thing I said to the Tesla retail team is like, look, the number one thing is that when someone comes in our store, whether or not they buy a car, the most important thing is they look forward to coming back to the store. That's it. Just like that's their goal. Make sure that when people visit our store, they look forward to coming again. That's it. Like, don't try to sell them something that they don't need. Don't try to sell. Don't sell. Just your goal is just to communicate and make people feel good. And we got a lot of opposition from the auto dealers, as you might imagine, and they were not happy campers about this approach. But anyway, we felt like, hey man, we want people to love it, love buying a Tesla all the way from like the initial buying experience to receipt of the car, ownership, the post-sales service experience. It's sort of about like you want people to fall in love. Like you want them to just just love it. So we thought we had to do it for that reason. We weren't sure if this made sense from an economic standpoint, or whether it was going to serve us poorly or well. We just knew that we didn't want to replicate the negative experience that most people have in buying a car. So anyway, we got the first retail store established in LA, and then shortly thereafter, another one in the Bay Area, in Menlo Park. In fact, this is where I first met Franz von Holzhausen. Franz, do you want to come up and talk?
So yeah, if I knew Tesla history then, when I first met you, I don't know if I'd be standing up here, but.
So as I mentioned, like I was like the chief designer, for Tesla, for the Roadster. But I sort of fully realized, like, man, there's definitely people who can do this way better than I can. And so, but then I tried at first to outsource the design of the Model S to a few different companies. That was a whole saga in and of itself, and that really didn't work out. So it's like, man, I actually knew that I couldn't do a great job of designing the Model S, because designing a four-door sedan that's beautiful is incredibly hard. Like, designing a sports car that's beautiful is relatively easy, because the proportions lend itself so well to beauty. But a sedan's proportions do not. So, asked around and was told, like, there's this guy Franz who's really great. I don't know if he's like gonna be, willing to jump, but he's really great, and you should go talk to him. And then I think it was the first meeting we had was actually at the opening party for the Tesla store, and it was a good party. So, like, I think, like, one thing Tesla's good at, like, we throw good parties, okay? I was like, okay, great. This is gonna feel real good. And Franz and I spent like a large portion of the night just talking to Franz at our first store opening party, and we really hit it off. Sort of really been like friends ever since. It's been a great honor working with you.
Yeah, and likewise. I think, in my first conversations with Elon, I had spent 16 years already in the auto industry. I was, in the early days of Tesla, I was driving an EV1 around because I worked for General Motors, and I was, experiencing range anxiety in Los Angeles, experiencing the, plugging in and having the neighbors come and unplug me in the middle of the night, and then not being able to get to work the next day. All those things that were kind of the trouble side of electric vehicles, but there's an aha moment when you just experience the acceleration, and even in an EV1, which, was heavy and not nearly like a Roadster. But that moment kind of always sat in my mind. I went to Mazda afterwards and continued to try to get somehow this green initiative going. But then when I met Elon and his real drive for, changing the world and really changing the automotive industry to be much better, I realized that there's no automotive manufacturer out there that really will do this in earnest and put their money down and not have it be an R&D project. It was always going to be an R&D project for them, and it was always going to be like, okay, our main kind of appetite is for internal combustion engines, but this electric thing or this hybrid thing, we'll dabble in it and see where it goes. But talking to Elon, and then subsequent to the party, I went to SpaceX, where I saw actually kind of the proof and a little bit of the genius behind it, and the ability to, okay, if this guy can really get rockets into space, then this car thing's not going to be that
although
hard.
I should say, technically,
Although at that time he hadn't quite got one there,
technically at that point we'd actually not succeeded in getting to orbit.
That is true. But you could see the determination and the drive, and I think that's where I realized that the drive and the character was there, and for me to kind of jump ship and against my inner circle of friends and family telling me, like, you are crazy to leave your career behind and go do this. But I realized that it was really the future in a future way, and that these guys were going to do it, and shame on me for not jumping on board. So
yeah, and I think just super randomly, in designing the SpaceX logo and name, and then the Tesla logo name, I'd worked with a couple of graphic designers that randomly knew Franz, and they said, yeah, they gave me like the thumbs up. And
one of my best friends was dating the girl who was working on
the graphics. So it's kind of a small. I think it was like Kimberly. I think.
Yeah.
So like Kimberly was like gave a good endorsement of me. Yeah, in fact, if you see sort of slight similarities between the Tesla name and the SpaceX name, it's sort of, there's a reason for that, because it was sort of done by sort of the same team. Yeah, anyway, so Franz joined basically I think you started mid-2008.
Yeah, around August 2008.
Yeah.
And we had talked several times about designing a sedan for Tesla, and of course this thing needed to carry 7 people. And
Well, I said that was my fault.
No, but thinking like, okay,
like, I gotta put my kids in here. Like, so it's like, Franz, we need 2 rear-facing seats. Okay,
This will be a good challenge.
Yeah, I think it was like quite a difficult set of requirements, and we didn't even have the money for a design studio. So the design studio in the beginning just was just a corner of the SpaceX rocket factory. So we basically just put a tent.
Yeah, we pitched a tent in, like my first day, we put up the tent, and that became the design studio. We had, I think, a couple contract guys, and we started in earnest. One of the first things we did was drive a forklift through a Fisker model, dump it in the dumpster, and that was basically the beginning of kind of clean slate, start over, do it the Tesla way.
Yeah.
Kind of jettison the past a bit.
Yeah, exactly. So we just started really from the beginning when Franz joined, designing the Model S from scratch. And one of the things that was obviously very important was to design a car that is meant to be an electric car, as opposed to a gasoline car that is then repurposed for an electric car. So the fundamental design, coupled with the engineering, we really need to design it for an electric powertrain and battery, and so it couldn't really be, particularly on the in the internals, derivative of a gasoline car, because it doesn't work. It sort of would be the equivalent of a horseless carriage. Like, you don't want a horseless carriage, you want a car. And we weren't really trying to follow any, we certainly weren't trying to copy or emulate any other car designs. It really was just, we need to design a car that's meant to be an electric car that looks great and achieves the functionality that we're aiming for. And it was just a tiny team doing the Model S design in a tent in the corner of the SpaceX factory.
Yeah, and it's amazing to think about where the car is today from its kind of little humble beginnings. So, yeah, thanks for getting that started.
Yeah, thanks for joining. So, yeah, and then going on to 2009. And just backtracking slightly, and so in 2008, we were really still trying to figure out how not to die. And one of the things was that I thought would really help is if we had a strategic partner, like one of the big car companies, to be a strategic partner. And so in October of 2008, actually, I think it was, I stopped over in Germany, in Stuttgart, and met with Dr. Weber, who is the head of R&D for Daimler, and said, like, look, we'd love to figure out how to work with Daimler. Is there anything that you guys need on the electric vehicle front? Is there anything we could do? And he said, well, they want to make an electric smart car, but they don't have a good source for the battery and powertrain. So I was like, okay, this sounds like maybe we could help here. And he said that, well, there's a Daimler team, a senior Daimler team that's planning to visit Silicon Valley and meet with a bunch of companies in January, I think it's like January 10th or something like that, of 2009. And I was like, okay, so we've got 3 months, okay. And he said that he would ask them to meet with Tesla and kind of make their assessment. So I was like, okay, wow. So then I immediately, as soon as I left that meeting, I called JV, and it's like, JV, we have 3 months to make a working electric smart car. David was like, what are you talking about? And it's like, okay, there's some challenges here because the smart car was not actually available in the United States.
Couldn't even get one.
You couldn't get one. They weren't shipping in the U.S. Did you want to tell
Yeah, sure. This was a kind of ridiculous, crazy story.
Yeah.
I mean, meanwhile, of course, we were all hard at work trying to make the Roadsters actually work in scale-up production.
Exactly.
So
It's not like we didn't have stuff on our plate.
this was quite a non sequitur. Yeah, so 3 months. We put together a rough plan on how we could even possibly achieve this. And first of all, we had to get a car physically, and the only place we could figure out to get one this fast was in Mexico. So, literally, the next day we sent an engineer to Mexico with about $20,000 in cash to go and try and.
It was legal. I mean, sort of. Sort of legal.
To purchase a smart car, and he drove it all the way back to San Carlos. And I think the day after that, we tore the entire, propulsion system out of it and started designing a custom battery pack, from scratch. We had ideas on how we had done the Roadster pack, of course, but that didn't fit in this car. It was way too big. So, a very tiny team, small SWAT team of engineers, prototyped and architected a one-off battery pack, a lithium-ion battery pack that could fit into the smart car.
Yeah, and I did make things slightly more difficult because I said, look, you got to put the powertrain and the battery pack in the car, and it needs to look unmodified.
Couldn't touch the passenger compartment.
Yeah,
so it had
exactly.
To,
you couldn't just put it in the trunk, like just have a big battery pack sitting there in the trunk or something. It's like it needs to look like it's a normal smart car.
So the battery was a big challenge. We had to invent this brand new battery pack in a couple months and build it. Then on the drivetrain, we had to figure out how to adapt a Roadster motor and power electronics system and charging system into the back of the smart car in this tiny volume. And amazingly, we were able to repackage that whole thing. That team didn't sleep a whole lot in those couple of months, and it was also through the holidays, which was great.
Yeah, exactly. Thanksgiving, Christmas.
But everybody was having the time of their lives. It was super, super fun. We were in a little teeny garage in San Carlos, trying to make this, smart car electric. And one of the things we realized pretty early on is that this was going to be the fastest smart car that had ever been made.
So this was amazing.
It had all the torque, would have all the torque of a Roadster packaged into this tiny little car.
It was so fast you could do wheelies in the parking lot.
Yeah, it was, anybody that got in that car, exited just with a huge smile on their face. They just absolutely loved it. So that car basically led up to the meeting where we, met with all the Daimler engineering leaders and executives.
Exactly. Let me tell you about how the meeting went. So the Daimler sort of senior engineering team shows up, and it was clear when they entered the building they were not excited about meeting with some American car startup, whatever, so they'd been told, that they needed to do this, and they were like, well, this is obviously going to be a waste of their time, and they're quite grumpy, actually. And we started off with a PowerPoint presentation, and they really didn't like the PowerPoint presentation, so I said, you know what? Why don't we skip the PowerPoint presentation? Would you like a test drive? And they're like, well, what are you talking about? What do you mean a test drive? I'm like, yeah, we made one. I'm like, made one? What do you mean? Yeah, we made one. So it's just outside. Do you want to drive it? And they're like, sure. So then they went out and test drove the insane performance smart car. As JB was saying, it's basically you can't exit that without a grin on your face. So they went from being a bit grumpy to be like, holy cow, this is awesome. And we actually, out of that meeting, it got our first development contract with Daimler to create an electric smart car. And that was really, I think if we hadn't done that, Tesla would have died, because the Daimler partnership gave us credibility that a major OEM was willing to work with us. And they also, they paid us for the development program, which is really helpful from a revenue standpoint. And then most importantly is that when Tesla kind of was running out of money around May 2009, and I had no money left. I'd given all of the money that I had remaining to Tesla. I didn't even own a house. And I had to borrow money from friends to pay rent. So I was like, man, I am out of resources. So I was like, we need. I just don't even have any more money to invest. So then we need to seek outside investment, and this is early 2009. And just to sort of paint the picture, General Motors and Chrysler were going bankrupt at the time. The idea of investing in an electric car startup was not popular. We would talk to investors, and they would be angry that we even called them. But thankfully, Daimler did invest, and then they invested $50 million in May of 2009, which was a lifesaver. So I just really, I'd like to just say thanks and give a hand to Daimler for that. I was like, So, without that investment, Tesla would have been game over. So they invested, thankfully, and that gave us the resources that we needed to get the company to moderately healthy position, and actually get us to the point where we could build Roadsters without losing money on every car. So our Roadsters that we delivered were significantly negative gross margin until about basically third or fourth quarter of 2009, because we had to redesign so much of the car, we had to change out suppliers, and so actually every Roadster we sold before, say, the second half of 2009 actually cost more money than it did. We earned less revenue than it cost to build. But by late 2009, we'd finally redesigned the car and changed that up. Most of our suppliers, and were able to generate positive margin on the car, and then we had positive margin on the Daimler development contract. So the combination of those two factors got us to a reasonably healthy position, but we would never have gotten there without the Daimler investment. And I think this is important because a lot of people think that Tesla was bailed out by the federal government or something like that. This is not true. We were bailed out, but by Daimler, not by the government. So they're the ones who deserve the credit here. We wouldn't be around. Tesla wouldn't be around if they hadn't helped out. In fact, we still have an ongoing program with Daimler for an electric B class, and we're there's a great bunch of guys. So.
Yeah, it's worth saying that first SMART program led to what became a pretty thriving powertrain business for Tesla in those intermediate years. We made a lot of profit, as Elon was saying, and did some great engineering work for Daimler, building a production SMART EV and then also a production EV A class, and today the B class, which is still shipping. And those programs also taught us a huge amount. Being a supplier to Daimler was not terribly pleasant sometimes, but it also, trained us in quality, and it trained us in some of the systems that they had used, for 100 years. So, we got to really accelerate up the learning curve on building some of these very complex systems and how they validated them and how they made them last for, hundreds of thousands of miles.
Absolutely. So, we just want to, express a huge word of appreciation for Daimler and their help with Tesla, and without which we would just not be around. So, yeah, thank you. So, and then sort of getting to the DOE loan, which a lot of people are aware of, and people, there's some people out there who sort of constantly beat Tesla over the head with this DOE loan thing, and it's important to appreciate what this program was about, which was, it was actually a program that was signed into law during the Bush administration, although it was executed during the Obama administration, but it was signed into law during the Bush administration. And it was a program that was intended to accelerate the development of energy-efficient cars. And one of the prerequisites for being in this program was demonstrating that you were a going concern, which is why this program was inaccessible to GM and Chrysler because they were bankrupt. But unfortunately, in the media, this got confused with there was the auto bailout, and then there was the energy efficiency loan program, which really got conflated, but are actually completely different programs. And the first money that Tesla got from the DOE loan program was actually only in March of 2010. And the way the loan program worked was that there were a whole bunch of milestones and of technical milestones and product development milestones that we could only invoice for the milestones after they'd been accomplished, and then Price Waterhouse would audit the financials, and then we would send a request to draw down the loan in little bits and pieces. So it would usually take maybe 2 to 3 months after we'd actually spent the money to receive any of the loan proceeds. So again, this is like really fundamentally different from what happened in the auto bailout, although a lot of people sort of think it's the same thing. And the timing that we started receiving DOE loan money was after Tesla was out of the danger zone. So if Tesla had actually needed the DOE loan when we were in dire straits, we would have been doomed. So by 2010, Tesla was actually in sort of a moderately healthy position, and the DOE energy efficiency program was meant to serve as a catalyst for the acceleration of energy efficient vehicles. And that was its purpose. So because people tend to sometimes say it was either completely necessary or completely unnecessary, and neither of those are true. The fundamental purpose, and I think the DOE did a great job of implementing it to that end, the fundamental purpose of the DOE loan was to accelerate the advent of sustainable transport. And it's very important to note that Tesla could have raised money from alternate sources. So this was not, we could have raised money from an equity standpoint or from a debt standpoint outside of the DOE loan program, but the DOE loan program was there. Our competitors were using it. So Ford, for example, got like $5 or $6 billion from this program. Nissan got $1.6 billion. Tesla, for the Model S program, got $380 million, and then $100 million for a powertrain factory to supply other companies. Fisker, I think, got 500. They got more than we did, 500 or 600. So, I mean, of the names that you've heard of, Tesla actually got by far the least, and I think did quite a lot with those proceeds. But it's important. Like this was definitely helpful and served a catalytic purpose, which was the intent of the program. But it was not a case of sort of being, as some have accused Tesla of sort of being propped up by the government or something that was fundamentally necessary for Tesla to exist. It was helpful and catalytic, but not fundamental. The Daimler investment a year earlier was fundamental, but not the DOE loan.
I think something most people always seem to overlook was it was a loan. It wasn't a grant. So, I mean, this is obvious, perhaps in the name, but we have to pay it back. And that was
Yes.
very different than the Daimler investment, which was an equity investment in the company.
Yes.
So this is something where we had to start planning on how we would pay that back and prove to them that we would pay it back.
With interest.
With interest over the expected period of time before we even could get the loan.
Yep. So I just want to make sure it's sort of real precise. Tesla is certainly grateful for this, and it was very helpful, but it was not necessary. It was not fundamentally necessary. Then going on to the IPO. So the IPO process was certainly an interesting roadshow. There's Deepak, who think did an amazing job on the roadshow. But it was funny. I mean, would meet with potential investors. Tesla is a company that tends to inspire either love or hate. People are rarely indifferent. Like, if you say like, well, how do you feel about Colgate? I'm like, it's okay. But with Tesla, it's like either it's like you guys suck or you're great, or like yay. So it's like tends to be very much a love, either love it or hate it. And so in the IPO roadshow, we'd sometimes meet with investors who would tell us just how stupid we were and that this was a waste of money and how dare we even take their time. I'm like, okay, thank you. And they would meet with some that are like, yeah, you guys, this is great. We're all in. We have like some great investors like Fidelity who, despite all sort of the negative news and stuff, has been like a stalwart supporter of Tesla through the years. So anyway, like that was the IPO, that was it was an arduous IPO, but we managed to raise, get Tesla public, and just sort of clean up the capital structure and raise a bunch of money from the public markets. Shortly after that, we became one of the most shorted stocks on the NASDAQ. So, for quite a while there, we were trading places as the most shorted stock on the stock market. I think we were trading places with Skull Candy, Travel Zoo, and Coinstar. But for who would be the most shorted? Okay, so anyway, then sort of, next big thing. Well, this was, also in 2010, and kind of time-wise, approximately the same time as the IPO, is that we met with Toyota, and Akio Toyota actually, came by and we had breakfast at my house, and he was sort of really interested in working with innovative technology companies, and so we thought, well, what are the ways that we could potentially work together? And we came up with three things. One was to do a sort of a joint EV program to do the new electric RAV4. The other was buying the Fremont factory, the former NUMMI facility, because Toyota had decided to shut down the NUMMI facility. And it's understandable because it was half owned by GM, half owned by Toyota, and it was half owned by like the portion, like what was considered the bad portion of GM. GM got split into two pieces. One was called Liquidation Motors. So half of NUMMI was owned by Liquidation Motors, half by Toyota, and it just sort of didn't make sense for Toyota to kind of be in that kind of a partnership. So they decided to shut down the NUMMI plant, and we said, well, this is kind of huge it's a huge plant for Tesla, and we don't have much money, but we'd be interested in buying that, and that was one part of the deal, and then the other was like was making an investment at the IPO. So they said that sounds cool. We'll make a $50 million investment at the IPO, which was actually really helpful to us when we were doing the roadshow, because people would ask us how we're going to compete against big car companies, and we say look, we've got the Daimler partnership, and Toyota's investing at the IPO. So it's like, those are good signs. These three parts of the deal were independent of each other. So it would be either all three could work out, or none of the three could work out. So they weren't tied together. They were just sort of three things that we thought would be good. So again, I'd like to thank Toyota for their support, and they were a huge help to Tesla. So thank you, Toyota. And then the Model S beta. So finally produced a Model S that was, close to the production design, or very close, really. And we unveiled that to the public, and it was quite well received. And we had a lot of people who put down deposits on the car, and that gave us like a big boost of confidence. It's like, wow, people really like the car. It looks like we'll be able to sell enough to pay for the cost of the factory and everything. And so that was, thank you for everyone for those that made those early purchase orders for the Model S. And again, without you, we wouldn't be around. So yeah.
It wasn't quite as exciting as the Roadster, launch event, but it was close. There was definitely some serious drama at at that first Model S, customer ride event that we had at Fremont, and I definitely remember a few crazy stories. I think at least one point we had one car, completely die with some huge firmware problem, and a thing we've done at all these launch events is we have a kind of a control center in the back somewhere hidden away with a bunch of engineers that can watch the cars via their wireless connection. And I remember this car that basically had a problem. Well, we opened all the doors and the trunk and the hood and everything and put it on display in front of everyone. And meanwhile, the engineers rewrote some of the motor control code in that car to ignore the sensors that had gone wrong and were the problem. So we put it into this kind of limp mode, and then got in and sort of very carefully drove it away at about 10 miles per hour, and it was great. Nobody ever knew there was any problem. We drove it back to the shop, and ultimately it was like one bad temperature sensor that had shorted out and caused this problem. But I think it was really amazing that we could, what we could do with this new software capability, because the Model S was the first time. This was the first time we had that ability to send new software to the car. So it was kind of foreshadowing, I think, how important this has become for the entire production fleet. Even on that very first day when we were, giving the first rides to customers.
Yep. So then on to Model S deliveries. Here we go.
Thanks, Nancy.
It's my friend Bill Lee, a stalwart supporter of Tesla from the beginning. So that was a big milestone for the company, delivering the first production Model S's from the Fremont factory, where at the time we were occupying just a tiny corner. And I think that was definitely one of the most joyful experiences in the history of Tesla.
It was a pretty awesome event.
Yeah.
Everyone was just, it's really, everyone had worked so hard for that time, and I think the whole company was there. Every single person, production employees, engineers, sales, everybody crammed in because they were so proud to deliver those first few cars.
Exactly. So, yeah. Right. So we'll go a little faster through some of these later years. Because I think these later years are better chronicled in the press, whereas the early years nobody knew we existed, so that's kind of lost in the midst of time. So we unveiled the supercharger network, which we hadn't actually told anyone about. So when people did the first reservations for the Model S, they had no idea that we were going to create the supercharger network. But we'd built into every car a high voltage DC bypass direct to the pack. That would enable high-speed charging. And this was critical to solving the long-distance travel problem. And we were certainly hoping that some other company or companies would create high-speed, convenient high-speed charging networks, but nobody did. So we're like, okay, well, we better do it. So yeah.
Yeah, it was pretty crazy. We literally had teams of a few interns that we were sending out to different travel rest stops and trying to have them figure out where the good places to put these superchargers would be.
Interns are great because they don't know what's impossible, so you're just like, just do it. It's great.
And Harris Ranch was actually one of our very first, supercharged stations out on Highway 5. And I just remember the craziest conversations trying to convince these ranchers from the Central Valley on how this supercharged station was possibly going to work. There were no cars yet. They'd never seen a Model S. They didn't believe an EV could even get there, let alone charge fast. It was fairly amazing how this all grew, and only 4 years ago.
Yeah, we were kind of amazed that they worked, actually. We were like, hey, wow, it works. That's cool. Most of the time. So that ended up being fundamental to really just answering the question of, like, can I drive my car long distances? And what it really comes down to is freedom. Like, when you're buying a car, you're really buying freedom to go where you want to go. If you're constrained, if you're tethered to your charge location, you don't have the freedom. So the supercharger is really about making it freedom, giving you the freedom that you want when you buy a car, and then making it real easy and convenient to go wherever you want. And then paid off the DOE loan. It's worth noting, Tesla was the first company to pay off all the automotive companies had either gotten direct government grants, or they had been in the loan program. Tesla was the first company to pay off the DOE loan. And in fact, we had to pay. There was a prepayment penalty, and we actually, because you had to pay the interest plus a penalty for prepayment, because the normal loan would have been paid off over an additional 10 years, and in this case, so we paid it off 10 years early, and just paid the penalty because we just wanted to, make it clear, like, look, this, it just felt like morally the right thing to do, so that's why we did it. And then,
that his goal wasn't to build the world's best electric car, but to build the world's best car that just happens to be electric. Tesla Model S.
What's been achieved here for the first time is to create an electric car that truly is the best car of any kind.
There we go.